going to review some fundamental algebra here. In particular, this section is about expanding brackets. This is a very important skill which will run throughout the whole of this course. And there are many cases when people are not quite as confident with this as they probably should be. So at the risk of sounding a little bit patronizing, I'm going to explain this in the way that it is explained usually to students when they first ever see this concept. Don't worry, the slightly patronizing talk about sandwiches will only last a few moments and then we'll get on to some more abstract examples. What do I mean by sandwiches? Well, suppose you're making a jam sandwich. For each jam sandwich, S, you will need 2 slices of bread, so 2 B's, and 3 scoops of jam, so 3 J's. So if you were making 2 of these sandwiches, you would of course need 4 slices of bread and 6 scoops of jam. But another way to look at this would be to say that 2 sandwiches is 2 lots of the original 2 slices of bread and 3 scoops of jam. How can these two things be the same? Well, we'll need 2 lots of these 2 slices of bread. In other words, we'll have to multiply that 2 by the 2b, giving us 4 slices of bread. We'll also need 2 lots of the 3 scoops of jam, giving us 6 scoops of jam altogether, and you can see that both of these versions are of course the same. So if we are multiplying a bracket just by a number, we multiply each of the individual pieces. So for example, if we wanted 3 sandwiches, in other words 3 lots of 2 slices of bread and 3 scoops of jam, we would have 3 times 2 is 6 B's and 3 times 3 is 9 J's. And of course we would need 6 slices of bread and 9 scoops of jam to make 3 sandwiches. Suppose now we volunteered to make a load of sandwiches for some friends. At first, 2 of them say that they would like a sandwich, and then another 3 quickly turn up and say they would like ones as well. In other words, how many sandwiches are we making? We're making 2 and we're making 3. So this is 2 plus 3 lots of 2 slices of bread and 3 scoops of jam. So to make the 2 sandwiches, we will need to make 2 lots of 2 slices of bread, that's the 4b. We'll need to make 2 lots of 3 scoops of jam, that's a 6j. But we'll also, for the other 3 sandwiches, need to make 3 lots of 2 slices of bread. We'll need another 6 slices of bread, and we'll need another 3 lots of 3 scoops of jam. We'll need 9 scoops of jam. So altogether, we'll have 10 slices of bread, 15 scoops of jam, and you can see that this is exactly what we would have got if we had immediately gone just to making 5 sandwiches. In other words, 5 lots of 2 slices of bread plus 3 scoops of jam. That would have immediately given us 5 lots of 2 slices of bread, 10 B's, 5 lots of 3 scoops of jam, 15 J's. This is really the important thing. Let's do it a bit more abstractly. If we have 2 brackets, let's suppose the first one has quantities A and B, and the second bracket has quantities C and D. So to expand these brackets, we'll have to do A multiplied by C, we'll have to do A multiplied by D, we'll have to do B multiplied by C, and we'll have to do B multiplied by D. Another way of looking at this is to say that first of all we multiplied the 2 things which were first in the brackets, then we multiplied the things which were on the outsides of the brackets, then we multiplied the things on the insides of the brackets, and then the 2 things which were last in the brackets. So this is sometimes called the FOIL method. Now many people are taught to expand brackets by using a grid method. That's absolutely fine and will give you the correct answers, but I'm going to suggest that at this level you really don't want to be stopping and drawing a grid every time you have to expand brackets. It would be a very good idea to get into the habit of expanding just by doing this, and not even by writing all this down formally. The more examples you do, the more confident you will become in just doing this nice and quickly. Let's look at some examples. Expand the following expressions, giving your final answers in the simplest possible form. So in part A, we have x plus 2 multiplied by x plus 3. If we multiply the two things in the first positions, we'll have x times x, which is x squared. If we multiply the things on the outside, we'll have x times 3, which is 3x. On the insides, we'll have 2 times x, 2x. And the last things are the 2 times the 3, which is 6. And now we can combine those two terms in the middle, so we have x squared, and altogether we have 5x's plus 6. In part B, we have to expand 2x plus 5 multiplied by 3x subtract 1. So this example shows you that you don't just have a single variable in every case. 2x times 3x is 6x squared. 2x times negative 1, we'll have to subtract a 2x. 5 times 3x, we will have 15x's, and 5 times negative 1, subtract 5. So as a final answer, we would have 6x squareds plus 13x subtract 5. Part C goes slightly beyond what we've looked at so far, because although our first bracket has two terms, an x and a negative 2, our second bracket has three terms, x squared subtract 4x plus 3. But the idea is the same. We have to multiply everything in the second bracket by the first term and everything in the second bracket by this second term. So, multiplying everything in here by the x, we will have x times x squared, which is x cubed. We'll have x times negative 4x, which is negative 4x squared. We'll have x times 3, which is 3x. Now we have to multiply everything in this bracket by the negative 2. Negative 2 times x squared is negative 2x squareds. Negative 2 times negative 4x's is plus 8x. And negative 2 times 3 is negative 6. And I'm sure you can see why I've written the terms like this, so that they are now easy to combine. Our final answer would be x cubed subtract 6x squareds plus 11x subtract 6. In this set of examples, we have more than one variable name, but the rules are exactly the same. So in part A, when we have to expand x subtract 3, y subtract 2, multiplying first terms, we have xy. Outsides, we have negative 2x. Insides, we have negative 3y. And lasts, we have negative 3 times negative 2, which is plus 6. And there is no further simplification we can do here. All the terms are about different things. We can't combine them. The next example combines things even more. In the first bracket, we have both x and y terms. In the second bracket, we have an x squared term and a term which multiplies the x and the y. But once again, our rules have not changed. 3x times x squared is 3x cubed. 3x times negative xy is negative 3x squared y. Negative 2y times x squared is negative 2x squared y. And negative 2y times negative xy is plus 2xy squared. And there is a little bit of simplifying we can do here. We'll have 3x cubed, but look, we've got altogether negative 5 lots of x squared y, and we have 2xy squareds. The last example is not particularly different, but again there's a complete jumble of the two variable names, and the second bracket has three terms. But let's just follow the same rules we've already established. First, multiply everything in the second bracket by the x from the first bracket. That will give us x cubed, subtract x squared y, plus xy squared. Now multiply everything in the second bracket by the negative y. That will give us negative x squared y plus x y squared subtract y cubed. And again, there's a little bit of simplification we can do. We've got x cubed, we can subtract 2 x squared y's, we can add 2 x y squareds and subtract y cubed. In this set of examples we have 3 things to multiply together. All we have to do this is to deal with 2 pieces at a time. Let me show you what I mean. In example A, when we have x multiplied by x minus 1 multiplied by x plus 2, well, let's begin by multiplying these first 2 bits together. X times x is x squared, x times minus 1 is minus x. Now, of course, that needs to live in a bracket because all we've done is combine these 2 by multiplying them. Now we still have to multiply by this x plus 2, but now we can apply our usual rules. X squared times x is x cubed, x squared times 2 is 2x squared, negative x times x is negative x squared, and negative x times 2 is negative 2x. Little bit of simplification, x cubed plus x squared subtract 2x. The next example again has 3 terms, but has introduced a bit of a mixture of variables. We've got x multiplied by y subtract 3x multiplied by x plus y plus 1. So once again, let's multiply these first 2 pieces together first. That will give us xy subtract 3x squared. Then we have to multiply by x plus y plus 1. So everything in the second bracket by the first term from here. That means everything in the second bracket times xy. We'll have x squared y plus xy squared plus xy. Now everything in the second bracket by this second term. Everything in the second bracket multiplied by negative 3x squared. We'll have to subtract 3x cubed. We'll have to subtract 3x squared y, and we'll have to subtract 3x squared. So a little bit of tidying up we can do. We've got negative 2x squared y's combining these 2 terms. And we've also still got the xy squared, the xy, the negative 3x cubed, and the negative 3x squared. In our final example with 3 brackets, we have to do a little more work because we have to work out what the expansion of x minus 1, x minus 2, x minus 3 is. Well, let's once again multiply these first 2 pieces together, but they are both 2-term brackets in their own right. So if we do that, we will get x squared, subtract 2x, subtract x, plus 2, which we still have to multiply by x minus 3. Of course, it will be easier if we simplify this before we carry on. Altogether, we've got x squared subtract 3x plus 2 to multiply by x minus 3. And now we can apply our same rules. Everything in the second bracket needs to be multiplied first by the x squared, then by the negative 3x, then by the 2. So multiplying the second bracket by the x squared, we will get x cubed, subtract 3x squared. Multiplying everything in the second bracket by the negative 3x, we'll get negative 3x squared plus 9x. Multiplying everything in the second bracket by the 2, we will get 2x subtract 6. And while there's no need to write things in this staggered way which I have, you can do it all on one line if you like. Writing it like this makes it easy to simplify our final answer. Because we've only got one x cubed, but you can see that we have negative 6x squareds we have 11 x's and a minus 6.